All right, this is the second way in which we can find bearing. It's just a different notation that we can use to write it. So this one goes from north or south. So you are either starting north and then you can go towards the east or go towards the west, or you start at the south and then go towards the east or towards the west. Okay, so here's three examples. First one, south. And so you can see here how it's written. South and 35 degrees towards the east. So there's not a positive or negative direction for your angles. You're just either going towards the east or going towards the west. Okay, then if you want to start north and then go 80 degrees west, okay, you're starting to do north, then west is to your left or counterclockwise, go 80 degrees that direction. And then this third one, north, 45 degrees east. Okay, so you're just going to take your cue from the problem and how bearing is denoted in the problem, and then that's how you're going to give your answer. All right, so number 9, the bearing from A to C is south 52 degrees east. The bearing from A to B is north 84 degrees east. Okay, and the bearing from B to C is south 38 degrees west, and a plane is flying at 250 miles per hour. It takes 2.4 hours to go from A to B. Find the distance from A to C. Okay, so a bearing from A to C. So you are beginning at A, and you are going towards C. So I'm just going to say this is A, and you are south. Let me kind of draw in my north, south, east, west. Okay, so south, and then 52 degrees towards the east. Okay, so this would be east, north, south. Okay, and then this is 52 degrees towards the east. And that, somewhere along that line, that is where you will find C. The bearing from A to B is north 84 degrees east. So again, you're starting back at A, and to get to B, you're going to go north, so you're straight up, and then you're going 84 degrees towards the east. So maybe something about like that. 84 degrees towards the east. And somewhere along this line, we will find point B. Then the bearing from B to C. Okay, so now your starting point is at B. Your bearing from B to C is south 38 degrees west. So kind of here's my north-south, my east-west. So south and 38 degrees towards the west. So about like that. We're going to call this 38 degrees. Okay, a plane flying at 250 miles per hour takes 2.4 hours to go from A to B. Okay, so my plane A to B, and it takes 2.4 hours to go 250 miles per hour. So if we multiply that out, we can find the distance, and that is 600 miles. Okay, so then this distance from A to B, let's change color. So this is 600 miles. Find the distance from A to C. So we are looking for this side B. Okay, now everything we've done with trigonometry so far has been based on right triangle trig. So we are going to have to find some angles in here and hope that we can find a right angle somewhere that's going to help us out. Okay, well, if we look here, I'm back at A. We've got an 84 degree angle. We have a 52 degree angle. So if I want, I could find this other angle at A. I could find this right here because north to south, straight angle, 180 degrees. So if I do 180 minus 84 minus 52, we get 44 degrees. Okay, so this whole angle is 44 degrees. I don't know if that's necessarily going to help me, but that's another piece of information that I have. Okay, well, I have 38 degrees here. I can then find this whole thing, but I don't know that that's really going to help us much. That whole thing would be 52 degrees. Again, don't really know if that's a help because I don't know just what that angle B is for this triangle. So I might kind of have to hold on to that thought. Okay, now we do have something. When I found the 44 degrees, that's that whole angle at A, but we could find those two smaller angles. So if we do that, okay, east, this is you have a right angle here. So if I have 52 degrees, then if I do 90 minus 52, that gives me 38. So this smaller angle right here is 38 degrees. And then that other small angle, this would be 6 degrees. Okay, that might be helpful because if we extend this line right here, and we have this east-west line, then this 6 degrees, here, let me erase this 44. I don't know that it's really helping us right at the moment. Okay, so this 6 degrees here is an alternate interior angle with this little angle up here at 6 degrees. Okay, because those east-west lines are parallel. So if that's 6 degrees, then I can find this angle at B. So if I do 52 minus 6, that gives me 46 degrees there. So I have 46, 6, and that's not right. I did something wrong. This was a 38. I accidentally erased something. So I have 46, the 6 in this 38 makes 44 total. Then if we subtract from 180, we actually find that angle C is a right angle. So that's going to be really helpful. So now we have a right triangle. I'm trying to find distance B. Okay, well, you can use sine, cosine, sine or cosine would be helpful. So I think I'll go from angle B and I'm going to do sine. So side B is going to be the opposite, and then the 600 miles, there's the hypotenuse of my triangle. So if I go sine of 46 degrees is opposite over hypotenuse, then I can just multiply. So 600 times the sine of 46 and 431.6. So B is 431.6 miles. Okay, and there's that one. Okay, number 10, they give you a picture. So a ship leaves port at noon and heads due west at 20 knots for 20 nautical miles per hour. So A is your starting point. Okay, it's going due west at 20 nautical miles for 2 hours. So in 2 hours time, from starting at 12 o'clock, and then at B, you're going to arrive at point B at 2 o'clock. You've traveled 40 nautical miles. Okay, then you turn and change course, this time north to 54 degrees west. So that's that 54 degree angle that's marked for you. So he changes direction, and at 3 o'clock, he is at point D. So 3 o'clock. So if he's traveled for 1 hour, then that means he's traveled 20 nautical miles. Okay, our job, we need to find two things. We need to find the current ship's bearing, where it is now, and the distance from ports. So we are looking for C, and then we are looking for the bearings from the original port. Okay, so north, south, east, west. Oh, sorry. Okay, then we are looking for this angle. Okay, so that's going to be our bearing. Okay, so, well, we certainly do not have a right triangle right at the moment. So we're going to need some help. Well, if you look over here to the left, this triangle BCD, you have a kind of smaller right triangle. If 54 degrees, you got north, and then 54 degrees to the west. Well, if I take 90 minus 54, that's going to be 36 degrees. So this angle here at B is 36 degrees. We have a right angle there. And then our other angle is going to be 54 degrees. Okay, so 180 degrees for my triangle. You also have these north-south lines. So this 54-degree angle at B is an alternate interior to the 54-degree angle at D. Okay, then what we can do is we can find a distance for B and a distance for D. We do want both of those distances because what we'll then do is use this large triangle, this large long right triangle, and that length C is the hypotenuse for this larger triangle. So if I start with 36, if I do sine of 36 degrees is opposite B over hypotenuse 20. And then I can also do cosine of 36 degrees is adjacent over hypotenuse and solve those. So I'm going to do that and I'll be back in a second. So here's both of the distances for B and D. So now what we have is we can look at this larger triangle. So if we look at here and then all the way across here, you have the 40 plus the 16.18. So this side becomes 56.18 nautical miles. And we can use Pythagorean theorem to find C. So I'm going to take a second and do that for you. Okay, so I did the Pythagorean theorem and found that the hypotenuse is going to be 57.4 nautical miles. Okay, now I need to find the bearing. So remember, I'm kind of looking for that theta. Well, what I'm going to do is actually find alpha, find that smaller angle of the triangle. So I'm going to do that by doing tangent of alpha, and then I'll use my inverse tangent. So now that I figured out that alpha is about 11.82 degrees, I can subtract from 90, and I'm going to get 78.18 degrees. Okay, so that is this theta, 78.18 degrees. So my bearing is north, and then I'm going towards the west. So the bearing of my ship from the original port is going to be north, and then 78.18 degrees towards the west. So you've got your distance to the ship and then your bearing.